Who's visiting from where? Oh, no, they're going to drive down, they're leaving on Sunday. He doesn't start school till like the 24th or something. But get this, he screwed up, forgot to renew his leases on the place to stay until October 3rd. That's okay, I'll just couch surf for a couple of weeks. My son.
But how do you even take all this stuff there?
Well, he has most of it already in storage. All he has right now is like 3 duffel bags and stuff. Okay, number 1 apparently. So we'll just do this as a little review.
I need help with
Just to
number
make
1
sure.
C.
Okay, a tank holds 1,000 gallons of water,
I get that part.
which drains from the bottom of the tank in half an hour. The values in the table show the volume V of the water remaining in the tank after T minutes, okay? And what you should notice, and we talked about this a little bit before, is that the volume of the tank, the volume of the water in the tank is not changing at a constant rate because the valve is on the bottom. Mr. Weaver, do that experiment for you guys. If you take like a water bottle or a Coke can or something and fill it full of water, and poke a hole in here and poke a hole in here, this stream of water comes out at a lower angle than this stream right here because the bottom one has more pressure on it from the volume of the water. And so in this problem, as the water drains, there's less pressure being put on the water, and so it's draining at a slower rate as it goes, okay? So, I don't know if that's important or not, but there you have it. All right, alright. If P is the point 15 to 50 on the graph of V, so we've got the point 15 to 50. It says find the slopes of the secant lines PQ when Q is the point on the graph with T equals 5, 10, 20, 25, and 30. Okay? And so what they're saying, Evan, is this is P, and then these are our points Q.
So it's not like
Yeah, and so at 5, the y coordinate is 694. This is 444. This is, I have to skip one. 111. This is 28. And this is 0. Okay? So you are going to have 1, 2, 3, 4, 5 answers. y2 minus y1 divided by x2 minus x1. 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 y2 minus y1, okay? So you get the slope each time, okay? Connor, I'm assuming that you got this all figured out. Am I right?
I got it all figured out too.
Okay, what'd you get for him? Set me up.
Negative 44.4.
Yes.
Negative 38.
Wow, Gabe, negative 38 point what? 8. Okay. Negative 27.8. And negative 16.6. Okay. All right. So as promised, the rate at which the water is draining from the tank is slowing down as the water level decreases. Okay. All right. Estimate the slope of the tangent line at P by averaging the slopes of 2 secant lines. Which secant lines would you like to choose?
Top one and the bottom one.
You want to do the okay? Hold on. Time out.
I just put
Time
random
out.
with
Time out.
Secant lines are shiny.
Kind of. So what we have is a graph that looks like this.
Yeah.
Okay? And we're trying to find the slope at this point right here.
That was the tangent.
That's the tangent line.
Okay.
So when they say you find the average by looking at the slopes of secant lines, they're saying like this from that point there to that point there. Okay? Okay. Shh. So it sounds like some of you estimated the slope of the tangent line by looking at the first point and the last point. okay? And some of you, what was another strategy that you used?
I just went to random ones.
Or you could all shout at the same time. Good God, is this junior high?
What?
Okay, can I get just one person? Yeah.
I use, like where x equals 20 and x equals 20.
Right, so you did the ones on either side of them, this one right here and this one right here, okay? That's usually the best strategy. Because remember, we want the points to be as close as possible to the actual point that we're looking for. So you would take the average of these two slopes right here and use that as your guess, okay? All right, C, use a graph of the function to estimate the slope of the tangent line at P.
Yeah, I don't really know how to do that.
Yeah, I don't really want to do that, but my recollection is that the kids that took the AP test last year said, you got to do this stuff because they want you to do this stuff. So this is dumb, but we're going to do it anyway, okay? And that's going to happen sometimes in this class. So what they want us to do is instead of using like the actual math numbers, they want us to estimate by looking at the graph. So the time is going to go on the bottom like always.
So does that mean you have to like draw your own tangent?
Yes, so
That
that's
sounds
done.
terrible.
Yes, I know, but again, they said we're gonna do it anyway. So the times are gonna go on the x-axis, and we have to go up to 30 by 5s. So I don't know, 5, 10, 15, 20, 25, 30. That's not enough. How about 5, 10, 15, 20, 25, 30. Okay? So those are our times.
You only have the small graph paper?
No, I have big squares in the cupboard if you want. I need to bring some out. Okay, so now the volume has to go all the way up to 1,000. So on my graph here, what do you want to go by? 50, 100, 100, 200, 300, 400, 500, 600, 700, 800, 900, close enough. Okay, so there'll be a point up there. And then if I graph 5, 6, 94. So 5 is this 1, 2, 3, 4, 5, 6 right there. Okay. And then 10, 4, 44. So 10, 1, 2, 3, 4, and then partway in the middle. 15, 2, 50. 10, 20, yeah, we can get that exactly. 20, 111. Maybe there. 25 is what? 28. Okay, so right there. And then 30 is 0. All right, so what we need to do then is we need to take and connect these points with a nice smooth curve like that. And we're trying to find the tangent line at where? 15? Is that right? Okay, so yes, this seems silly that we would be doing this because we can do better than this with math. How about if I do something like that? Does that look about right? Okay, so now this is where we're going to do the little triangle here. Okay, so what's the rise right here? 50, 100, 150, 200, 250. Actually, it's down 250. And then this one right here is going to be maybe, what?
0.75.
Well, I think it's more than that. If I went from here to here, these are each, what, 1 1/4? So 1, 2, 3, 4, 5 makes 6 1/4 plus another 1 1/4, 7 1/2. You like?
Yeah.
Okay, so my rise is about negative 250. My run is about 7.5. So if you go 250.
Hey, that gives us the same answer.
What the heck? 33.3. Negative. Okay. That's what we got for part B also.
Yeah.
Okay. All right. So that's kind of silly, but again, they want you to make the connection between the 4 different ways of viewing a function. This we don't have an equation for it, so we couldn't do it that way. But we took the words that told us the tank was draining, We took the table, we made a graph, and we did it in all different ways like that, okay? So that's what's up with that. Okay, not doing 2 because it's pretty much the same as 1. Now you know how to do it, so do it. Number 5, Dave.
So number 1, how would you take the average and put it into the equation?
How would you take the average and put it what?
Into like an equation, for example? Because you have a slope, I would just really bad slope.
Right, so if you were asked to find the equation for this tangent line, we now know that the slope is negative 33 1/3. Okay?
Same evidence.
And we know that this point right here is 15,250. And so remember that fun equation that we used yesterday? So you could go y minus y1 equals the slope times x minus x1. Okay? And there's your equation. Thank you though for bringing that up because we're actually not done with this problem. This is an important thing. This is time in minutes, and this is volume in gallons. So what does the slope of this thing, what would be the units? Gallons per minute. Okay, so we've sort of talked about this already, but you need to understand that because this comes from a table, it has a real world meaning. And in this case, it would be the gallons per minute that are leaving the tank, the rate of change of the volume of the tank. Okay? All right, 5. What?
Are you still talking about 1?
Yeah, sorry.
You're talking about...
No. 5. All right. So we played this game a little bit yesterday. We are starting with the ball that's thrown into the air with a velocity of 40 feet per second. And we know from physics that from that we can come up with an equation for its height at any time t, which is going to be 40t minus the force of gravity, 16t, or half the force of gravity. You guys said 1/2 gt squared yesterday, right? AT squared, sorry. And since we're dealing in feet here, not meters, gravity is 32 feet per second squared, not 9.8, and so that's why this is 16, not 4.9. All right, so part A says find the average velocity for the time period beginning when t equals 2 and lasting all of those different times. So t equals 2, what does y equal? 16. Digit now. Okay. Okay, so this is going to be essentially our x1, and this is going to be our y1. And now we are going to play the same game that we did before. If the time period has lasted 0.5 seconds, what is my new time? 2.05. What is my new height? 2. Did I write down the wrong thing? 2.5, sorry. 2.5. Okay, so how do I find my second y value?
You plug it in, but it equals 0.
It equals 0? Awesome, I'm okay with that. So now to figure out the average velocity, I go y2 minus y1, so 0 minus 16 over essentially x2 minus x1, so 2.5 minus 2. So that is going to give me a velocity of negative 32 feet.
So
Okay.
how'd you get the 2s?
How did I get this 2?
No, like the...
This 2?
Yeah, the sub 2.
It says that they want it after 0.5 seconds. So, so I just add 0.5 onto this. Okay, and then to get the y2 rate, I took this number and plugged it into there and trusted her. Okay? All right, so then we can play again with a different time. Now they want to know what the average velocity is over a period of only 0.1 seconds. So my new time would be 2.1. And my new y value would be 13.44. You got what? Connor was wrong?
Well, I just cracked it. I played at one, not two.
Ah, gotcha, that was it. Okay, so we play the same game again. The average velocity over this time is y2 minus y1, which is going to be negative 2.56, right?
Yeah.
Divided by the change in time, which would be in this case 0.1. And so move the decimal over one place means that now I'm looking at an average velocity of negative 25.6 feet per second. How do you feel about that? Super duper? All right, what's my new time period? Okay, so my T2 is 2.05. My Y2 is what I get when I take this and plug it into that equation. 14.76. Okay, so my average velocity over that time period is, if I subtract those, I'm going to get negative. Oh, okay. Yeah, I'm confused, so those things, okay. 1.24 divided by 0.05, so yeah, I have to double that, so it's going to be negative 214.8 feet per second. Okay, is there a part I?
Yeah. And then
Oh, IV, okay, 0.01. So what do I get when you plug that in? 15.7584. So if you go that minus that and then divide, you get an answer of negative 24.16 feet. That's a nice feet per second. Okay? All right, so yes, Evan is correct. That's a lot of busy work. We're not really getting anything out of that. Estimate the instantaneous velocity when t equals 2. You're going with 24? Negative 24?
Oh, that's what I meant. I put the about.
40
symbol.
minus 32, 64, yes, negative 20. Because these numbers are getting closer and closer to negative 20. All right? Okay, what else?
7, 9.
7?
7B, not 7B. 7 and just 7.
Yeah, just call 7 would be a good choice.
It's just like all those points minus. Like I did this really thing. We were watching the doctor's school.
I got confused on the bus. So.
Okay, 7A.
It's like
Find the average velocity for each time period. So this is going to be just change in distance divided by change in time, right? If you look at the chart, what is the location at 1 second? 1.4. What's the location of the cyclist at 3 seconds? 10.7. So how much did their location change? What's 10.7 minus 1.4? 9.3, good. And how long did it take them to travel that distance? 2, so that means their average velocity over that time period is 4.65 meters per second, okay? What is the change in their distance from time t equals 2 to time t equals 3? 5.6?
that's the answer.
Well, that's the final, well, yeah, because you're dividing by 1, yeah. Okay, so 5.6 divided by this change in time is only 1. So that means their average velocity over that time is 5.6 meters per second, okay? Do you guys get the drill?
Yes.
Okay, so you figure out what their position is, subtract it. This time you're going to divide by 2. For this one here, you have to figure out what their position is again and subtract it and divide by 1.
Can we skip 7B?
Okay.
It's the same thing where you
The 7B, you have to make a graph and then estimate it. Okay, no, can't skip it. Support it.
So we don't have graphs.
I just estimated.
How do we find the what?
Never mind, that was a stupid question.
From the
Alright,
table?
Okay.
Yeah, I got that.
Okay. Can you go back to that?
Uh-huh.
you got like 9.3 over 2, you subtract that from the sum of the table, right?
Yeah, so I looked at the, right. 10.7 minus 1.4 is 9.3, and 3 minus 1 is 2. So it's the same stupid thing again, it's y2 minus y1 divided by x2 minus x1. Every single thing.
When are we gonna learn the class?
When are you gonna do the what? I don't know, I might not teach you this year.
Yeah, I did.
You seem like you're really good at this way, so.
I know, but I'm over it.
What'd you get for 7?
True. There's no 8. I'm just going off your graphs.
Okay, so now we're supposed to make this graph again. So we have obviously the guy's gone nowhere at 0 seconds. After 1 second, he's gone 1.4. So maybe here. After 2 seconds, 5.1. After 3 seconds, it is a distance of 10.7. I'll go by 2s, right? And after 4 seconds, it's 17.7. 10, 12, 14, 16, almost 18 right there. And after 5 seconds, 25.8. 2, 4, 6, 8, 10, 12, 13. All right, so once again, a nice smooth curve. Okay? And we want to find their average, or their instantaneous velocity when t equals 3. So instantaneous should trigger in your brain for now and all eternity slope of the tangent line. Okay? Average velocity is the y2 minus y1 divided by x2 minus x1. Instantaneous velocity is the slope of the tangent line. Okay? So make ourselves a little triangle. Quiet. 4 of these is 1 second, so 1, 2, 3, 4. So that's about, Gabe, you go about 1.5 seconds. Because you totally nailed it last time, so I'm going to do. So this is about 1.5 right here. Each one of these squares is 2, so 2, 4, 6, 8, 9.
I don't know.
9.5. Okay, so 9.5 divided by 1.5 is, you don't say, but that's your answer. 6.3 repeat. And that would be meters per second. Okay. Number 9. Number 9. Is this the last one?
Yeah.
7.
Number 9. Let's do some trading.
I think I could do it, but I was feeling real lazy. I was like, maybe I could mess over.
Yeah.
Too much math.
And then I'll see you guys.
I just don't know it.
And things are fun, you know, I'm just kidding.
No, that won't for many, many days. Low on the priority list. You have functional
I said no.
You're not okay with it, John, you find.
Why don't you just take the stuff from the other one?
Clashing.
I think it will.
Can I go grab my calculator?
Yeah, all right, so this one is a little bit unreasonable because there are there's a lot of points that they want us to plug in, correct, to the 4 decimal places.
I end up just like going up.
So There's got to be an easier way to do it, right?
Gotta be another way.
On your calculator,
And then you get
you
value.
graph it at what? I know, but isn't there an even easier way than that? Should we write a program?
Well,
You want to write a program?
that'd be easier after.
You want to write a program?
I don't know how.
Okay, hit the, never done this before, hit the program button.
I don't have all the numbers.
I mean, I've never written a program for this particular
Freaking put
thing.
fruit in there on my calculator.
Oh, okay, so you can help us out when we struggle. So go over to new, where it says create new, and hit enter. What should we call it? Slope, average,
Stupid.
stupid. Love potion number 9. I'm going to stick with slope, so that
Calling it stupid.
you can call it whatever you want.
Mine's automatic.
And then hit enter.
Well, shouldn't you be more specific? Like,
Yes, right. So when she says stupid, she's not going to remember what that is.
what about a slope, like of what?
We don't know. Could be a slope.
So it'll find the slope manually?
Yeah, we're just going to do a quick little slope thing. So what I'm getting at here is that I'm hoping to be able to just type the function into the y equals, and then you guys enter the x1 and the x2, and it should give us the answer. Okay, that'll be pretty easy to do. All right, so you ready? So now hit the program button again, and then you want to go over to the I/O thing. That's the input/output menu. Okay, and then hit number 2 for prompts. And I can't do subscripts here, so I'm just going to call our x1 is going to have to be A. Okay. I don't know how to do subscripts on the calculator. Okay, nope.
Did you just do regular A?
Yep, oh, I did alpha A. Okay, and I'm going to do this
When
again.
I do prompts, nothing happens.
Because you gotta hit enter after the slope. You just hit enter and then
So now yours is called stupid prompt.
No, it just says,
Okay,
just put.
now I'm going to hit program again. I'm going to go over to the I/O, and I'm going to hit prompt, and I'm going to call this alpha B. Okay? So far, the exciting program that we have written for our calculator is it's going to say, don't do this, but if I were to run this program, it would say, it's going to go, tell me what A is, tell me what B is. All right, awesome, thanks, we're done. Okay, so what we want to do is we want to have the calculator do some math with those two numbers. Okay, the first thing we would like it to do is take those two numbers and plug it into an equation that we have written in our y1. Okay? Yeah, so you're going to have to enter the equation into y1 for this to
So we're
work.
gonna have to do it twice by x and y?
Just wait. All right.
They keep messing up.
If you have the new operating system, you should be able to go to alpha F4 and it will give you the Y menu. Okay?
oh yeah.
And then you just hit enter. And we would like to take into Y1, we would like to enter the value of A.
Wait, how did you do the alpha what?
Okay? I did alpha F4. If you do not get that fun little menu there, then I'll show you how it's going to be.
Okay, I'm just gonna do one. It sounds awesome.
Okay, the other way that I'll show you in a second, okay? We're going to now take this value that the calculator gives us and we're going to store it as, the store button is above the on button.
Wait, how did you get the A?
The
after
store
the
button is
Y1?
above the on button, alpha A.
Did
Okay,
you put the parentheses there?
yeah, you got to put the parentheses around it. I'm going to store that as C, okay? And then now I want to play again, and then I'm going to show you, Patricia, how you would get the Y1 up there if you don't have the new thing, and it's cumbersome, but here's how it goes. You hit the bars button.
Wait, are we all doing
You can do alpha F4 and get Y1 again. Okay, then you go over to the Y bars. Okay, and then you hit enter for functions, and then you hit enter again for Y1. Okay, so that's a little bit longer, but it'll work. Now we're going to take the second x value, which is b.
Alpha what to get the A?
I'll show you that in a second. What?
To get the Y1, alpha what?
Alpha F4. Okay, and then the arrow is the store button above the on button. Okay, and then I'm going to store that value as D. Okay. All right. So now we are ready for the calculator to do some work for us.
Yeah.
We want to take y2 minus y1, right? So I'm going to go parentheses alpha d minus alpha c. No. These are two separate answers that I'm going to get when I put my two separate x values into that function. Okay? I don't know. I don't have a social life. Divided by, no, I've never tried this before. Hopefully it's going to work. So this is y2 divided by, or I'm sorry, y2 minus y1. Now we're going to go divided by x2 minus x1, right? So that's going to be alpha b minus alpha a. And we're going to store this answer as a variable. What would you like it to be? E. Okay, so that's going to be alpha e. And then for our last line, we would like the magic calculator to tell us what that answer is. So I'm going to hit the program button again. I'm going to go over to I/O input output, and I would like to choose number 3. I would like the calculator to display for me what E is.
Will it show the commas? Like, will it?
I don't think so, but we'll find out in a minute. Now, the mistake that you are going to make with this program is for this program to work, you must enter the function into y1. Okay? If there's nothing in y1, it will give you an error because you're telling it, plug this value into y1, and it goes, you didn't, and I got, and so shut down. Okay? Or you will forget to change it to the problem at hand.
How do you get it to say display?
You go program. You go over to I/O. You can push enter if you want. You can push enter all the way through.
All day long.
It doesn't matter. There's nothing to do at the end, so it doesn't matter. Okay? All right, so now let's get out of this. So go second quits. Okay? And now you are back to your home screen. Okay, so we have to test and make sure that this works. So let's pick a particularly easy function.
1 plus x.
1 plus x. All right, so let's find the slope between 2 points and 1 plus x by hand. So what would you like the x1 to be? 4. What would you like the x2 to be?
6.
6. So if x1 is 4, y1 should be 5. Y2 should be 7. I guess we didn't have to do the math because we already know the slope is going to be 1, right? Okay, so we're going to run our program. So have this entered into y1. Hit the program button, and now we are going to execute program slope. Hit enter. A is our x1, so that was 4. B is our x2, so that is 5. And then cross your fingers, and when we hit enter, it should say 1. Okay? All right? So now when you're doing these problems, you don't have to do all that busy work.
So what if like x squared?
It should work for anything. So for example, the equation that they want you to do for number 9 is sine of 10 pi over x. So type that in as your y1. Sine of 10 pi over x. If you want to be in radians, and I failed on that on the first day, but I'm good now. Okay? So now here's the nice thing. If you go back to your home screen, you don't have to go back to the program menu again. If you just hit enter, it will run it again. Okay? So what is our x1 now?
I guess the lead with
2.
2.
No. It's actually 1.
PQ. Oh no, yeah. P is 1 comma 0.
Yeah.
So our x1 is always going to be 1, and our x2 for the very first one is now 2, and it tells us that the slope is 0.
Oh, that's so terrible.
Is that what you got when you did it by hand? Yes? Okay, so you have something wrong, we'll figure that out in a second. Now I'm going to hit enter and I'm going to run it again. My x1 is always going to be 1, and now they want my x2 to be 1.5, and now we get that as an answer, and they want it to 4 decimal places. Okay, so it's still a little bit of busy work, but it's a lot easier now. You can just go through and just keep hitting enter, 1, and then the new point, 1, and the new point, 1, and the new point.
Just learn some street.
Huh?
Just learn
Some street cred, really? By writing a calculator program? I'm pretty sure I lost some street cred there.
It's not for math varsity.
Oh, okay. Did you get yours to work, Mary?
Yes.
Okay. All right, so finish up 9A if you didn't do that already. And then use those answers to answer the question, do the slopes appear to be approaching a particular value? No. So hungry.
It's like this. This is awesome.
So what do we write? So we just write down the.
So you write down those 10 answers or whatever it is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 answers. Pua, if you're watching this, you missed on a bad day.
Every day's a bad day.
Sorry.
Yeah, in this class there was bad.
It's seriously gonna be the end of it.
This last movie,
Yep.
you can do it.
I can.
Okay, so as you guys are working through this, you should notice that unlike the other examples, the slopes here are not approaching a particular point. So we are in part B supposed to look at the graph and figure out why. So we are looking at points that are close to 1, 0. So I'm going to try and zoom in so that I am going from maybe -2 to 2. And then it looks like I have a pretty small amplitude. So I'm going to make my y values, I'll try the same, -2 to 2. Okay? So you guys can kind of keep doing what you're doing and look up here up the graph as you work. Well, this is a trigonometric function, right? So it's oscillating, it's changing. Where was the original point that we were trying to look at? 1, 0. So that's somewhere right around here. So if I'm picking secant points, I started at 2, right? Right? So that would give me this slope right here. That's why we got 0. And then I did 1.5, which will maybe be up here somewhere. So that's going to give me a slope of this. And then I'm getting closer. But you see that what's happening is the y values of those points are changing drastically. So as I get closer and closer to that point, I'm not getting closer and closer to the slope of the tangent line. It's varying quite a bit because it's a trig function, okay? Okay, then for part C, by choosing appropriate secant lines, estimate the slope of the tangent line at T. So let's zoom in to the point that we're looking for and see if we can find a way to pick some good numbers. Okay, so I'm going to zoom into that. Okay, so it's still really going crazy. So here's my point right here. So how far do you think I could go to either side and still be able to get good? So and I'm staying on this branch right here. Did you do this, Connor? No. Okay. So if you look at this, do you understand what I'm saying? To estimate the slope at this point right here, I want to stay right on this branch of the equation. So not very far. So if this is 1, I've gone 1.01 and it looks like I'm still okay. Maybe 1.02. So if you try plugging into your calculator, if you use x1 as 1.01 and use 1.02, and then maybe to keep the negative people happy, we could go the other side and try 0.99 and 0.98. Then maybe those numbers will be getting closer and closer to a particular value. I don't know. Okay?
Yeah.
Yeah, it's going to be a big negative number. As you can see from looking at the graph, if we estimated the slope of this tangent line, it would be a very large negative number. Okay, so if you plug in those values, you should get close to something large and good. All right? Okay, you guys all right with that? All right, so I know this is really going to bum you out, but that's pretty much almost all the time we have. We only have 5 more minutes, so we will not be able to get to today's learning target. So finish up those assignments. If you still have a little bit of work to do on it, turn those in to me. Relax for the last 5 minutes, and we'll play again tomorrow.